Hello everyone, welcome back to Spectrum classes. This is my next video on the topic ground state term symbols. In this video, I am going to discuss some tricks and the concept behind the ground state term symbols prediction for many of the elements which are present in the periodic table. Here I have summarized few of the elements for which I am going to solve, and I will share a trick with you so that you can easily identify the ground state term symbol and predict less than 30 seconds. So let's start with the video for the prediction of ground state term symbols for the elements. So here first I am going to discuss the term symbols for equivalent electrons, right? So here for a closed shell means S2, s orbital can occupy maximum 2 electrons with antiparallel spin. So here this is the closed shell. Similarly, p shell. P is having maximum of 6 electrons with antiparallel spin. So this is again a closed shell. D10 and F14. So for this type of configuration, we are having term symbol 1s0. How we are having this 1s0, that I will explain in the next slide. Similarly, for the half-filled subshells are S1, means the maximum number of electrons it can occupy divided by 2, we will get the half shell. So S can accommodate maximum 2 electrons. So here we are having 1 electron. P can accommodate maximum of 6 electrons. So here we are having 3 electrons. Similarly, D5 and D7. So you are all are aware about this half-filled subshells. And for this half-filled subshells, we are having this type of term symbols. So guys, you please don't worry. I'm just telling you the trick to write this within 1 second, right? So, but before giving you the trick, I'll just explain the whole concept behind this and then I will give you the trick. Here first I will solve this for closed subshells. So say I'm taking the example of, which is the simplest example, for S2. So S2 has a maximum of 2 electrons with antiparallel spin, as I told you earlier. And for this S, we are having ml is equal to 0. And this ml is equal to 0 corresponds to capital ML, means for both the electrons it is 0, and again ms is equal to 0. Both are in antiparallel spin, right? So if you have any confusion regarding this small ml, capital ms, then you can check my previous video on the same topic, right? I have discussed all such things in the detail. I will also give you the link in the description box. So here, corresponding to this ml and ms, we are having capital L is equal to 0 and capital S is equal to 0. Corresponding to this L, we are assigning the term, whether it is S, P, D or F. So corresponding to this 0, we are having S term. Here, this is the spin multiplicity, which is equal to 2s plus 1. So 2 into 0 plus 1, we will get 1. And here it is 0. 0 stands for this. This is the value of J, means total angular moment. And the value of the total angular momentum, L plus S to L minus S. So here L is 0, S is 0. So we are ultimately having the value of J is equal to 0. So in this manner, for the completely filled shells, we are having one as 0 term symbol. Now coming to the same example for half filled subshell. So here I am just solving this for S1, right? So here S orbital is having 1 electron. ML is equal to 0 for this S, and here MS is equal to 1 by 2. So on having these ML and MS values, we are assigning the capital L and capital S values. So L is equal to 0 and is equal to 1 by 2. Let me tell you, if you are a little confused with these terms, then you can skip this part and you can directly use these terms. Calculating the ground state term symbols, capital L is equal to 0 and capital S is equal to 1 by 2. Corresponding to this L is equal to 0, we are assigning the term S, and 2s plus 1 will be equal to 2. 2 into 1 by 2 plus 1, we will get 2. And what about our j? J is L plus S to L minus S. So j is equal to 1 by 2. So here we are having 2s 1 by 2, right? So this is how we are having for the closed shell and for the half-filled shell. Now I will explain again with the P6, D10 and F14. So here you can check. Here I'll just explain P6 example again. So ML is equal to plus 1, 0 and minus. These two are antiparallel, right? So overall ML, if we count for all these electrons, so here plus 1, plus 1, 0, 0, minus 1, minus 1, right? So we will cancel out that and we will ultimately get ML is equal to 0. If ML is equal to 0, then that corresponds capital L is equal to 0. Similarly for MS is equal to 0. Therefore, capital S is equal to 0. And for this L, we are assigning capital S. And for multiplicity corresponding to this S is equal to 0, we will have 2S plus 1. So here we are having 1. And the value for J, as we have discussed in our previous slide, so this is 0. So in this manner, we are again having 1s0 for P6. Similarly, you can calculate for D10 and F14. Now coming to the half-filled shells. So in the half-filled P3 corresponds to ML is equal to 0 and MS is equal to 3 by 2. This 3 by 2 is having values plus 3 by 2 to minus 3 by 2. I have discussed this in P3 configuration, right? So you can go and check that so that you will have better understanding what I am saying about this ML, MS and L and S, right? So, but while calculating the ground state term symbols, we can skip this part and we can directly calculate this also. I will tell you later on. So L is equal to 0 here, S is equal to 3 by 2. L is equal to 0 corresponds to S and 2S plus 1 for this S we will get 3 and for J value it is L plus S to L minus S is 3 by 2. So here we are having this type of term symbols and here the term symbols change. Here we are having 5S 5 by 2 and here we are having 7S 7 by 2. So probably you are guessing the trick. Here I am showing you the trick. So the trick is n plus 1 s n by 2 for the half filled, right? N is number of electrons here. So n 1 electron. So 1 plus 1 is 2 s n by 2. So 1 by 2. This is n, right? P3 n plus 1 4 n by 2. Here this is j and s is the term. D5 6s 5 by 2, F7 8s 7 by 2. So this is how you can predict the term symbol for half-filled subshells. Similarly here for the closed shell we are having 1s0. So please keep it in your mind. Right now I am showing you the ground state term symbol. So please remind it this ground state term symbol. Other than this ground state term symbols, there are sometimes have number of terms. So I will show you the example of this type of cases. So helium S2 configuration. So S2 will have 1s0. Beryllium S2 again 1s0. Neon P6 P6 1s0 again. Magnesium S2 configuration again 1s0. Zn is having 3d10 4s2. So it is again 1s0. So you can easily predict their term symbol. Now coming to the half filled. So 1H is 1s1. So 2s1 by 2. Lithium is 1s1. Hydrogen, lithium, sodium and rubidium all are belongs to the same group, 1s group. Right? So 1 means 1 electron in the s orbital. So for all these elements, we are having the term symbol 2s1 by 2. Now coming to the copper 29. So copper 29 is what? It is an exception because it is having D10 4s1. So it is again 2s1 by 2. I am showing you some more examples. So here we are having 7n. So nitrogen, antimony, these all are the fifth group elements and for these P3 we are having 4s. Now the next is technetium and this is belongs to the manganese group. It is D5. So D5 means 6s5 by 2. So it is very easy for you to predict the term symbol without calculating it, right? Now coming to the next, for a p subshell. So in the p subshell, we are having electrons p1 to p6. So how we are going to understand that? So p1, p2 is equal to p5, p4 respectively. How it is so? That I am showing you here. If we are having p1 electron, so one electron is here. And what about the p5? P5 electron is having 5 electrons with one vacancy. It is this red color suggests the hole. Okay, so one electron or one hole, two electrons or two holes. So in this manner, these two configuration P1 is equal to P5 and P2 is equal to P4. And now coming to the P3. P3 is the half filled, P6 is the full filled. So you just guess for P6. So P6 is 1s0. I also discuss an example of P6, that is neon. Now coming to the P3. P3 is the half-filled nitrogen. So nitrogen, for nitrogen we are having 3 electrons. What is the trick? N plus 1. So 3 plus 1, 4. S and 3 by 2. Right? N by 2. This is the term symbol. Now coming to the P1 and P2. Here I am just giving you another trick for P1 or D1. So P1 gives you P and number of electrons 1, 2 electrons will be there. So 2p is the ground state term symbol for p1. Now coming to the d1, that I will discuss in the next slide. So there you will get 2d. So 2d will be the term symbol. P2 is equal to p4. So p2 I solved in my previous video. I will give you the link over there, and this has these three term symbols: 3p, 1d and 1s term symbols for p2, and here are the j values, right? So you just see out of these three, 3p will be the ground state. Now I am coming to the examples. 5b. So 5b is equal to what? 1s2, 2s2, 2p1. So this is p1 configuration. So p1 configuration belongs to 2p. Right. Here I also mentioned the j value. So for j values, if it is less than half filled, the lower is the j value for the ground state. And here we are having F9 halogens. So halogens 9F or 17 chlorine, we are having P5 configuration. P5 configuration is like P1 configuration, right? But it is more than half filled, so 2p 3 by 2 will be the ground state. Now coming to the C6. So C6 is the P2 configuration. P2 configuration will be equal to P4 configuration. Here I have mentioned that oxygen 8, which is having P4 configuration. And here we are having the 3p term symbol as the ground state term symbol. So for less than half filled, 3p0 is the ground state, and for oxygen 3p2 is the ground state. Here I am showing you the trick. Again, we write ground state term symbol, right? So I just made the same trick here. GS is equal to ground state, and GS here I used to memorize like this. Greater is the S first and greater is the L for the ground state. Greater is the S. First you have to choose greater S. Out of these three, 3 is the maximum value of S. So 3p as the ground state term symbol out of these three. So greater S and then greater L will be the ground state. Now coming to the J value. Less than half filled, lower J value will be the ground state. If more than half filled, more J value will be the ground state term symbol. So here that is the only difference. For C6, PP0, for oxygen 8, PP2, the ground state. I hope you understand these tricks. Okay, now coming to the D subshell. So for D subshell, we are having D1 is equal to D9, D2 is equal to D8, D3 is equal to D7, and D4 is equal to D6. Now coming to the half filled D5 and coming to the full filled D10. So for D10, what will be the term symbol? 1s0. For D5, 5 plus 1, 6, S 5 by 2. This stands for manganese. This is the example of manganese and this is the example of zinc 30. Now coming to the D1 and D9, how we are showing it. So D1 and D9, one electron in the D1 and for D9 we are having one hole. D2 we are having two electrons but for D8 we are having two holes. So in this manner you can understand that these are the values and I also written over here in P also I have written there D electrons is equal to D10 minus E electron except this 5 and 10. Okay, because these are the half filled and full filled. Now, these are the ground state term symbols. So, in my previous slide, I have discussed that D1 or P1 will gives you 2D and 2P, right? So, D1 gives you 2D. Now, coming to the D2. D2, I have solved in one of my video and it has this many term symbols. Out of these term symbols, what I suggested you for the ground state, greater is the S. So out of these five term symbols, we are having same multiplicity for this P and F. And what I said next, if we are having same multiplicity, then go for greater value of L. So greater value of L is for F because P stands for L is equal to 1 and F stands for L is equal to 3. So the ground state term symbol is 3F, right? Now coming to the next D3, 4F and D4, 5D. So if you forget sometimes, so start with the D, F, F, D, right? Exception is 46 palladium. 46 palladium is having exceptional electronic configuration. So the electronic configuration which is expected is, it is of nickel D8 system, right? But rather than having D8S2, it is having D10S0. It is an exceptional electronic configuration. And what is the term symbol for this palladium? So you can remind it, it is very important actually. So 1s0. In this manner, you can write down. Now coming to the non-equivalent electrons. So for non-equivalent electrons, I am just sharing the information related to the chromium 24, which is again having exception. The electronic configuration for chromium 24 is expected is this, and here 3d4 4s2. This is expected, but it is not like that. It is having 3d5 4s1 electronic configuration. Here is the change. Now coming to the incomplete subshells out of these subshells. So these are the incomplete subshells and we have to write down the term symbol for chromium from this subshells. So the easy way to write the ground state term symbol for this type of configuration is like that. So first draw D5 and then S1. This is actually alternative method. And if I sum up all these, then I will get L is equal to 0 and S is equal to 6 by 2 is equal to 3. Now coming to the term symbol. So term symbol will be what? So this is for L is equal to this is S and for 2S plus 1 multiplicity is 3 into 2 plus 1 equal to 7 and here S is equal to J is equal to 3 because 0 plus 3 and 0 minus 3 will get 3 value. So this is the term symbol. This term symbol is applicable for molybdenum 42. How many tricks we have discussed? We have discussed for completely filled shell, we are having 1s0. For half filled, we are having n plus 1 s n by 2. And for P1, if I am having P1, then I will get 2P. If I am having D1, I am getting 2 capital D greater S than L. And for less than half filled, lower will be the J value. And for more than half filled, higher will be the J value. chosen for the ground state terms. So I hope guys you understand the concept and number of tricks which I have discussed here in this video. If you find this video helpful, please like, share and subscribe. Thank you all. Thanks for watching.